In simple English, this video will just explain the ShellSort in as simple way as possible. Here's the official introduction. In a world of ever-growing data and time constraints, the need for efficient sorting algorithms has become paramount. Enter ShellSort, a remarkable technique that amplifies the power of the insertion sort. Join us on a captivating journey as we explore the simplicity and elegance of ShellSort, unraveling the secrets behind its ability to transform the insertion process into a more efficient and lightning-fast sorting algorithm. Let's start by reminding ourselves of the beauty of insertion sort. In this example, we have 6 numbers. We go through the list and we check to see they're in order. Essentially, when we have a number that's not lower than a number previous to that, then we move it forward. So this way, the lower numbers I move towards the beginning until the list is in order. Looking at our original list, you can see that if there are lower numbers at the end of the list, it makes the algorithm less efficient. It would be good if we could move lower numbers closer to the beginning. We can see in the following example, we're going to move some of the lower numbers and swap them with higher numbers. So you can see if you watch the 7 and 8, they move place with the 4 and 2. Let's see how that's done. Using the ShellSort, we're going to use half the length of the list, which is 3. And if we start at the beginning, if we look at numbers 3 apart, 4 is lower than 7. We move along, we've got 1 and 3, they stay the same. Now we've got 8 and 2. 2 is lower, so we move it. Now on the next pass, we want to reduce the gap. So using the floor division, we went from 6 to 3, now 3 to 1, which is the insertion sort. So we know when we use the insertion sort, we finish up with an ordered list. We start off with the Python code for the insertion sort, and we use the print statements to see the different stages of ordering the numbers. So you can see here order comparisons in the while loop when we have a number that's less than a number before it, and the final lists. Now what we're going to do, we're just going to add some code that's going to do the same thing as the insertion sort, but where the gap is 3 rather than 1. So essentially, we're going to use the print statements again. We can see that we have the original list. We run this code that moves the items that are 3 apart, so the lower one moves closer to the beginning of the list, and then we end up with the insertion sort using less operations. So you can see here we've just simply written the code that performs that action. So you can see when we can add the operations inside the additional code, and you can see that at the moment with a short list there's not much difference between the whole insertion sort and the more efficient. Obviously the operations are less now in the insertion. But what happens if we used a longer list? So here's an example that we used in a previous video. So now we've got 10 numbers. So imagine if we used a gap of 5. So first of all, let's run the code from the insertion sort by itself. So you can see we've got quite a few operations with the insertion sort, but it does work. Comes with a sorted list. Now let's add the additional code first, run it first, and you can see with this code now we move some lower numbers to the beginning of the list, and now we've got the 0 and the 1 and the 2, for example, at the beginning, and that means there's less operations in the insertion sort. So you can see here the original and the revised insertion with lower numbers moved to the beginning just by running this code beforehand. So the larger the list, the more effect this will have. But you can see that we can move lower numbers to the beginning or the first half of the list, and that will help the efficiency of the insertion sort. So what we're doing here is we're moving the gap in the first example from 3 and then 1, in the second example 5 to 1, but you could essentially run as many passes as you wish. So we could move the gap from 5, then down to 3, then down to 1, for example. So with the ShellSort, we run the gap larger to move lower numbers to the beginning or earlier in the list to help with the efficiency of the insertion sort. And that's what we're doing. We can look at the actual code of the ShellSort. So here we've got our original example that we showed at the beginning of the video, and when we run it we can see the list at the beginning. When we have a gap of 3, remember we move numbers, lower numbers earlier in the list, and then the insertion puts the list in order. If we want to look at what's happening, we can add this print statement. It gives you an idea what's happening during the operations where numbers are swapped. So we have 718432. We can see that the 4 and the 7 have been swapped. Nothing has been swapped here because 1 is not greater than 3, but here 8 and 2 have been swapped because 8 is greater than 2. And then the difference of 1 is essentially the insertion sort, which we already know. Now what happens is the list is longer. So here we've used the longer list example, and let's take out the print statement for now. And let's run this. We can see we've got a space of 5, a space of 2 because we're using the floor division from 10 to 5 to 2 to 1. So you can see the operations with a longer list are being reduced because it's more efficient. Again, if you do want to see the workings, the inner workings of the code, we can add the print statement, and you can see here essentially we look to see if the lower number is greater than the number that's further up in the list, so 5 and 1, so we don't need to swap them. So when we have a number like 7 and 2, we want to move the 2 to the lower position, so we swap the 7 and 2. So that's what happens in the ShellSort part of the code, and that happens with the gap of 5, happens with the gap of 2. So once we get to our gap of 1, which is our insertion sort, it will take less operations because the list has lower numbers at the beginning and higher numbers at the end. So you can see here, although the list is not in order, it is mainly constructed of lower numbers at the beginning and higher numbers at the end. So therefore the insertion sort is more efficient. So that's how the ShellSort is done in the Python code.
There is a great new opportunity for anyone interested in learning about Python or any other areas of computing. In the next year, new courses will be added to the Alps Academy, and they will be available to you for free. Written by university professors, they will be specifically designed for international students, which means they'll be easy to understand using simple language. They will even be helped to improve your English if you're interested. How can this help you? Well, leave a comment. Any suggestions you make could be turned into a course. Motivated learners deserve equal access to opportunities. Help us to help you.